sandwich application.
Who can demo at the drop of a hat?
Well, I just talk about what's available. Like you mentioned that you release software. Yeah, and we've got our software open source. Maybe just inform each other what's out there to play around with other people's stuff.
Okay.
We could do that right now, to be fair. Food's not here.
Yeah, we could do that. Yeah, why don't you start?
All right. So one of the things we've been working on for ages is ClickHash, or the project we call AnonLink. Excuse me.
Oh, no, I worked it out.
ClickHash is a Python library and command line tool, if you will, for making clicks. ClickHash, CLKhash.readthedocs.io, which you can't see. And also available on GitHub. So if you go github.com N1 Analytics, that happens to be where we store everything at the moment, there's a few things that are linkage related that might be interesting. ClickHash and AnonLink are open source, and we have this entity service thing, which is the REST API for doing linkage. At the moment, that is private, but I plan to open source that now anyway, so we'll just make that public.
Ribbon cutting.
Come on.
Yeah.
Password manager, which needs to be unlocked, which I'll do on this screen.
Oh no, something went really wrong.
Right. Okay, which is now public. So the entity service is a, I can even go to a version of it that's online. So a almost current version, 193, is hosted as anonlink.data61.xyz, which is just something we're hosting for testing purposes. We have no SLA. This is not going to be something we run as a service. Rather, it's just a nice way to demonstrate things and show it off. Come on. And that's now destroyed in my computer. No. The gist of it is really just a REST API around the AnonLink library, which has been open source for a year or so. That lets you do, the library lets you do multi-party linkage. So based on composite Bloom filters, the library has a bit of support for blocking and for multi-party linkage. It outputs in various types, like give you the raw similarity scores, go through a decision model and give you back a mapping entity to entity, and also some variations with permutations. Sorry, I can zoom in a little. Now the bottom half of this is also open source, and that's ClickHash. So that's where we have this Python library, but also a command line tool and a client-side REST API for turning CSV or just raw PII into Bloom filters. So given either at the command line with a CSV file of raw inputs and a schema which describes how you want the hashing to occur, weights for particular features, the shared secret, it will just compute a list of Bloom filters, encode them. And there are two versions of that. ClickHash and the, what do we call it, Jacob? Encoding service?
Yes.
A REST API does the same thing. So if you have the ability to run Docker somewhere and you want to be able to hash, make clicks very fast, it does that. And I guess it's worth saying on the AnonLink side, we're pretty proud of how fast it can go. This API, so this is currently comparing that many bloom filters per second at the fastest it goes, that is 570 million bloom filter comparisons per second, which took a lot of work to get to. So this isn't a single machine running on a single CPU that's doing bloom filter comparison, but it's parallelized across multiple workers. It's running quite optimized assembler code to do the actual disorsum coefficient stuff. Pop counting is all done at like assembler level, even though it's all wrapped up quite nicely as a Python library, and we're giving it away. Feel free to use it. Anyone else want to jump on details about QuickHash or non-link? Since we're, as you can tell, I just decided to do this right now.
We welcome pull requests.
We welcome pull requests. There's a lot of things which we implement the interesting stuff at a non-link, like the Python library. We do interesting experiments like Wilco just talked about, and ideally they'll make it into that library. But it's a bit more work to get something into the REST API, into the service, like scalable, trying to be robust, things like that. So this service you can deploy to Kubernetes. As I said, there are Docker containers for this. So there's a whole stream of DevOpsy style work that's gone on to make this possible. But interesting record linkage features can easily be added, and yeah, we very much welcome.
Can you talk a bit about the architecture behind this? Is this based on something like Spark, or is it something that you build yourself?
That's a different diagram from what I was expecting. It's a Python kind of native framework for distributed compute based on Celery. So all of the communication between components goes over a Redis queue. So the support services are where all the data gets stored. So we have Postgres or any external database with SQL where we're going to store projects, runs, what we're doing, but not the actual entity level data. Redis is job information. Like I have 10,000 small tasks of comparisons to do at once. They'll all be kind of queued up there. And then the bulk of our data is actually stored in a S3 object store. We use the open source MinIO, which means we can deploy it on premises and not require access to S3. But essentially, that's just a place you can store a file and get it back in chunks. So if you want to say, give me the 10,000th to 20,000th byte of that file, it will stream just those chunks. You don't need the whole thing. And so we've defined binary formats for how we will store or how we store CLKs so that we know exactly what to expect at different parts of memory there for efficiency again. And all the top stuff, yeah, we have a Flask-based Python web app which answers the phone when you ring, and it puts all the work out via Celery to the back-end workers, and they scale horizontally quite nicely because it's at least the similarity scoring component scales really well. The solving, we kind of have a special anointed worker which has to have more RAM because the solving step for us at the moment has to fit in memory, and so we make sure that gets allocated to a node which has more memory. But we're planning on working on improving the similarity score component, the classification component to scale better too.
So you mentioned about 5.7 million matches per second or something?
570 million.
570 million. And that's on how many nodes?
4 at the moment. 4 relatively small maybe M3 mediums. It'd be 16 cores.
16 cores.
I'm pretty sure.
And you mentioned one of the workers has
more RAM. More RAM. I'm thinking in the order of 16 to 30 gig, not massive amounts of RAM. What you can get.
And would that node become a bottleneck eventually?
Yep, for scale. And we've identified that, and we want to work on that and get more of that process to be streaming as opposed to all in memory. That classification step, yeah. But it's also an optional, well, not really an optional step. If you don't need the classification component, you just want the similarity scores, you can ask our service just to do that, and then download the terabyte of similarity scores and do it yourself. If you've got that memory, which you probably do.
And the blocking is, so this is 570 million records in origin.
Without any blocking.
Without any blocking. So it's pairwise.
Blocking support in terms of the REST API is on our backlog, but not super high up. Multi-party support is kind of the big one we're hoping to do in the next few months.
And the 570 million is pairs or records? Single records, pairs of records?
Comparisons, so pairs.
Comparisons, okay.
Clicks per second.
But isn't the problem in that because you don't do blocking, you could just get way too many?
So,
I think, I'm sorry, James can comment on this as well. They're impressive numbers, but if you get such a huge number of pairs, your classification problem, which is already, if you do blocking, is very imbalanced, becomes extremely imbalanced. It would be interesting of your 500 billion comparisons if you can show a histogram.
yeah.
And let's say if you have, I don't know what your data sets, let's say you have 10 million each, you get your 500 trillion comparisons. Even if you get 10 million matches, finally these 10 million matches out of a 500 billion comparison is going to be...
We're going to see a lot of that in
It's going to be a kind of a strong problem where you find your like 4 out of a million, or your galaxy, which has certain characteristics of your universe, right? So I think blocking is hugely important, and it's challenging. And classification, I'm going to talk. Well, Ryan and I are going to talk about this afternoon. Classification is a problem which nobody's really looked in. We all just kind of do everything. Similarity threshold. That's not the answer. That's
so
pretty much not what you want to do if you have one-to-one matches, if you have complex matching, you have temporal matching. That's where research will go into it. How do we do improved classifications on these massive amounts of similarities?
So basically what we do is we apply a similarity threshold and then we do the greedy thing where we go down the list and accept anything.
That's wrong. That's not how we should do things. Everybody does it, but that's not the best way. It can't be right. In many situations that really approach. But even if you do that, if you have, I've seen this with lots of data sets, right? You get matches which the monotonicity doesn't work in practice.
Okay.
Because you get all your twins at the beginning. It's all highly similar, right? You don't get the people who have moved, as we've seen contemporarily, right?
yeah. So one
That's one of the areas where I think research will go in looking at how do we make use of, because what you're basically doing is you're building a similarity graph. And if you don't do blocking, you have a click. You have a complete graph.
Don't do blocking. We're saying here's a tool which we've kind of forced ourselves not to do blocking so that we get acceptable scale parameters. But you can block and then compare this block quickly via REST API, get the answer out and use that. So in itself, like that as a tool is hopefully useful.
So I'm not saying it's bad, right? I'm just saying there's so many aspects, and the comparison of bit errors is very fast. But doing more, I don't think is often helpful. I think it's more doing less, but doing less in a clever way.
Yeah.
That's what, I know you can comment on.
That's always been the way we've gone for it. I mean, you guys do the CLK stuff, and we're still back at the field to try and maximise the quality.
Yeah.
The first thing we always do is the blocking to try and reduce the comparison space. So minimise the comparison space and try and maximise what you do with those. I mean, you use the CLKs and you're pushing through impressive numbers, I've got to say. I think Peter's point is a lot of that computation is kind of not necessary. But if you're doing the blocking outside, then you are reducing the space.
Yeah. And we wanted, this might be preempting Jacob's talk later, but when we're going to multi-party lineage, we knew we would have to do blocking. But we really wanted to see, can we get to like New South Wales population sizes without having to go to that? So we've got all the raw similarity, got that whole matrix of scores, and then we can look at classification with that whole space as the input and do interesting things with that. The other thing I wanted to mention from this is the hashing schema. Zoom in on that a little bit. decided that we needed to define some sort of way to tell our tools, whether it was the REST API or a command line tool, how you want to deal with my data. And so that would include information like what sort of hashing to do. So there's a whole lot of configuration of, like, in this case it's using double hash, sorry Wilco, as opposed to what he was talking about, what we use now, with Lake 2. And then for each feature, so kind of global settings, and then per feature, how to weight it and do things like that. And now we've done quite a few experiments about generating these automatically and optimizing the schema depending on the data set. And you're talking about that as well tomorrow? Is that correct?
Yes.
Okay, cool.
Tomorrow or today?
That's tomorrow.
And that could be, like, with more work to make more general, kind of take the next step as well. If we defined, how you want to solve, how you want to like use the click information, like that's kind of defining the schema for what you've got, and then we could do the same for, and now here's how to do the next solving step. That's in a nutshell our click tool. Yeah, have a look on GitHub, give it a star, download it. If you've got Python, you can run both the linkage part and on-link directly, and ClickHash. ClickHash actually includes Windows executables, and it's a very easy Python install, not much dependencies, because we have to run it in government institutions who are sometimes not completely up to date with things. And on the entity service side of things, yeah, I'd love to hear if anyone wants to use it or tries it out. Bare minimum starting point is Docker and Docker Compose, and then everything should just be pulled from the internet and go. Have your own local REST API. And I see lunch is snuck in while I've been blabbering on, so let's go eat.